In this video, I'll be teaching you everything you need to know about coordinate geometry, and we'll start right now. Hello everyone, my name is Shirley and welcome back to my channel. If this is your first time here and you'd like to improve in your MS skills, start now by subscribing and clicking the bell so that you don't miss anything. Let's take a look at the first part of coordinate geometry. What is a line segment? A line segment is part of a straight line with two endpoints with specific length or distance. Any point dividing the segment in a particular ratio is known as an internal point. So to find the point P, which is in between A and B, we use this formula. So P xy is equals to mx1 plus mx2 over m plus n, comma, ny1 plus my2 over m plus n in big bracket. So remember to memorize this formula if you want to find the internal point. Let's look at this example. The diagram shows the position of two football players P and Q. The coordinates of players P and Q are 4, 6 and 40, 45 respectively. Player P wants to kick the ball to player Q, but the ball lands at 2/3 the distance of the straight line towards player Q from player P. Determine the coordinates of the ball when it touches the surface of the field. So let the coordinate of the ball to be B, xy. Okay, so I draw a straight line here and I label P 4, 6 on the left and Q 40, 45 on the right. And then here would be the ratio, okay? So it's 2 out of 3 parts, which means that this M is 2 and this N is 1 because total is 3 parts. Okay, so now we're going to use the formula to find the coordinate of B. Okay, so B, I'm going to put it here, B xy. Okay, so I write down the formula first. So N x1 plus M x2, okay, over M plus N, comma, N y1 plus my2 over m plus n. Okay, and then we substitute the values inside. So let this to be x1, y1. This will be x2, y2. Okay, so let's solve this. So n is 1, x1 is 4, plus m is 2, x2 is 40, then over m plus n, so 2 plus 1, okay, comma, and then n is 1, okay, y1 is 6, okay, plus m2, okay, m is 2, and then y2 is 45, and then over m plus n, so it's 2 plus 1. Okay, remember your big bracket because it's a coordinate. Okay, so it's equals to, okay, let's solve this using the calculator. So 40 times 2 and then we plus 4, which is 84 over 3. So 84 over 3. Okay, and then the other one will be 90 plus 6 and then over 3. So 96 over 3. Okay, so let's calculate this. 84 divided by 3 is 28. And then 96 divided by 3 is 32. So this is the coordinate of the ball. What are parallel lines? Parallel lines are lines that do not meet each other and therefore do not intersect at any point. Two straight lines are parallel to each other if and only if m1 is equals to n2. What are perpendicular lines? Perpendicular lines are lines which meet at right angle. Two straight lines are perpendicular to each other if and only if m1, m2 equals to -1. Let's look at the following example. Let's look at this example. Given P 73, Q 22, and R -14, find A, the equation of the straight line that passes through point P and is parallel to QR. So which means that we have to find what is the gradient of QR. So let's find what is the gradient of QR first. So MQR, okay, is equals to, so I'm going to use the formula which is 4 okay, minus 2, okay, over negative 1 minus 2. So we'll get negative 2 over 3. So this is the gradient of QR, okay? And then we're going to use the coordinate of P. So coordinate of P is 7, 3. Okay? And then after that, we're going to put inside the formula y minus y1 equals to mx minus x1 to find the equation of the straight line. So y minus 3 equals to, the m is negative 2 over 3, okay? X minus 7, okay? So here will be the 3 I shift over, become 3y minus 9 equals to negative 2x plus 14. So will be 3y equals to negative 2x. Then we have 14 plus 9, which is 23. Okay, so plus 23. Okay, so we move everything to the left, so it becomes 2x, okay, plus 3y equals to 23. So this is the answer for A. Okay, now let's solve for B. Okay, the equation of the straight line that passes through R and perpendicular to QR. So perpendicular now, okay, we're going to use the M1, M2 equals to negative 1. Okay, so to find B, I'm going to put this into this formula. Okay, so M1 is, we found just now here, this M1, okay, so which is negative 2 over 3 times with M2 equals to negative 1. So to find M2, that will be 1 over, will be 3 over 2, positive, okay. Now let's sub into this formula to find the equation of the straight line. So mx minus x1, okay, so y minus, so now we're going to use the coordinate of R. So R is negative 1, 4, okay? So it will be y minus 4 equals to, so the m is, I'm going to use m2, so it will be 3 over 2, okay? X will be x minus minus 1 will be plus 1, okay? Then this 2 I shift over, become 2y minus 8 equals to 3x plus 3. So will be, here will be 0, 3x minus 2y, okay? Then 3 plus 8 will be 11, okay? So plus 11. So we're going to move it, swap it around. So it become 3x minus 2y equals to negative 11. So this is going to be the answer for B, okay? And also, and then find the coordinates of S such that both lines intersect. So to find both lines intersect, okay, we're going to find the, use the simultaneous equation to find the intersecting point. Okay, so let's solve this. Okay, to find the intersecting point, I'm going to use this as equation 1, this equation 2, okay? And then, you see, I try to use the elimination method, okay? I'm going to make the x the same. So for here, the first one, I times with 3, okay? So I'll get 6x plus 9y equals to, so 23 times 3 is 69, okay? And then after that, equation 2, I times 2. So it will be 6x minus 4y equals to negative 22, okay? And then I minus, so 6x minus 6x, no more already, will be eliminated. And then 9y, okay, minus minus become plus, so become 13y. And then after that, 69 plus 22 will get 91. Okay, so y will be, so 91 divided by 13, so we get 7. Okay, now we substitute y equals to 7 into either 1 or 2. So if I substitute sub y equals to 7 into 1, okay, to find my x. So it will be 2x plus 3y equals to 23. So it will be 2x equals to 23 minus 21. Okay, so let's solve this. So 23 minus 21 is 2 and divided by 2 we get 1. Okay, so therefore the coordinate of S, which is the intersecting point, is 1, 7. So that's the answer. To find the area of polygon, which is a triangle with vertices A, B and C arranged in order, we use this formula. Half modulus x1, y1, x2, y2, x3, y3 and go back to x1, y1, which is equals to half times modulus x1, y2 plus x2, y3 plus x3, y1, And then you have to minus x2, y1, minus x3, y2, and minus x1, y3. Okay, memorize this formula if you want to find the area of a triangle. To find the area of quadrilateral with vertices A, B, C, and D arranged in order, we use this formula. Half modulus x1, y1, x2, y2, x3, y3, x4, y4, and go back to x1, y1, which is equals to half modulus x1 times y2 plus x2, y3 plus x3, y4 plus x4, y1, and then we minus x2, y1 minus x3, y2 minus x4, y3 and minus x1, y4. Okay, remember this formula if you want to find the area of quadrilateral. Let's look at this example. ABCD is a parallelogram which diagonals intersect at E. Given A, -5, 3, B, 0, -2, and C, 3, 5. Find A, the coordinates of D and E, and B, the area of parallelogram ABCD. So first of all, I'm going to look at the coordinates that they give us, which is A, B, and C. So I try to sketch out so that I can see the position and then I can see the order so that I can find the area of parallelogram, okay, without making any mistakes. So A is -5, 3 is -5 here, and then 3 is around here. So it's around here, okay, A, -5, 3. Okay, then B is 0, -2 is around here, okay. So B is 0, -2, and then C is 3, 5, which is around here. It's just an estimation, yeah. So, and then I can expect my D to be around here. I'm going to label as XY, okay. So A, find the coordinates of D and E. I'm going to find what is my coordinate of E first, because they say that the diagonals intersect at E, means E is somewhere in the middle, okay. So I'm going to use the midpoint of AC to find the coordinate of E, okay. So for A, to find, let E to be XY, okay. So I'm going to use the midpoint of A and C, so it will be -5 plus 3 over 2, okay, and then 3 plus 5 over 2, okay. For those who don't know how to find midpoint, the formula is x1 plus x2 over 2, okay, comma, y1 plus y2 over 2, and then in bracket, okay. So equals to, so this -2 over 2 is -1, and then it's 8 over 2 is 4, okay. So coordinate of E is -1, 4, okay. So to find the coordinate of D, I'm going to use the midpoint, which is E, equals to the midpoint of BD, okay. So I'm going to do my working over here on the right side, okay. So E, we already found, which is -1, 4, okay. So it's equals to the midpoint of BD, okay. So it's going to be x plus 0 over 2, and then, okay, y minus 2 over 2, okay, and then let's solve this. So -1 is equals to x over 2, okay, so therefore x is -2. And then, so I'll make this line longer. Okay, to find y, so it's 4, okay, equals to y minus 2 over 2. So this one bring over, is 8, 8 plus 2 is 10, so y is 10. Okay, so now we have gotten the coordinate of D, okay, which is -2, 10. Okay, so now after we gotten this D, we can find the area of the parallelogram. So D is -2, 10. Okay, so we got this already. So now we find the area of parallelogram. Okay, I'm going to write down my coordinates of ABCD. Okay, so easy for me to refer. So A is -5, 3. Okay, B is 0, -2. And then C is 3, 5. Okay, and then D is -2, 10. Okay, so I'm going to put into the formula to find area of parallelogram. So area, okay, of ABCD, okay, is equals to half of modulus. So I'm going to write the coordinates of A, B, C, D, and then go back to A. Okay, so A is -5, 3, B is 0, -2, and then C is 3, 5, and D is -2, 10, and then go back to A, which is -5, 3. Okay, let's solve this. So this is half, okay, modulus, -5 times -2 plus 0, 5 plus 3, 10 plus -2, 3, And then after that, we minus 0, 3. Okay, minus 3, negative 2. Minus negative 2, 5. Okay, then minus negative 5, 10. With modulus. Okay, after that, we use our calculator. We'll get 34 minus negative 66. Okay, and then after that, let's calculate this. 34 plus 66 is 100. So it's 100. So 100. Okay, so the answer is 50 units square. So that's the answer. To find the locus of a moving point from a fixed point which is constant, we use this formula, PA equals to R. Okay, so PA, we have to find the distance, which is x minus x1 whole thing square plus y minus y1 whole thing square, and then you square the whole thing equals to R. And then after that, we square both sides, so we get x minus x1 whole thing square plus y minus y1 whole thing square, and it's equals to R square. Let's look at this example. The diagram shows the locus of a moving point, Pxy, that touches the x-axis at a point and is of fixed distance from a point A, 3, 4. Find the equation of locus of P. Okay, so for this, okay, the formula is PA equals to R. Okay, so to find the distance of PA, we use this formula, which is x minus x1 whole thing square plus y minus y1 whole thing square, and then equals to R. And remember to square root this. Okay, so we're going to sub the value, so this is x1, y1. Okay, and then the R is the radius, so I'm going to join this to here. Okay, so for this, because it's 90 degrees, okay, so for this, the A for radius is 4. Okay, the R is 4. So it'll be x minus 3 whole thing square plus y minus 4 whole thing square, and equals to 4, and then the square root I shift over to the right side becomes square. Okay, so now I'm going to expand all the brackets. So it'll become x squared minus 6x plus 9 plus y squared minus 8y plus 16 equals to 16. Okay, so now I'm going to arrange it in order. Again, everything moves to the left so that it's equals to 0 on the right. Okay, so this will be x squared, okay, plus y squared, and then I minus 6x, then minus 8y, okay, and then this is 16 plus 9, and then a minus 16, so I'll get 9, okay, so it's equals to 0. So that's the answer. To find the ratio of distance of a moving point from two fixed points which is constants, we use this formula. PA over PB equals to M over N. So we're going to use the distance formula to find the distance of PA and PB. So for PA, it will be bracket x minus x1 whole thing square plus y minus y1 whole thing square, and then we square root the whole thing over x minus x2 whole thing square plus y minus y2 whole thing square, and then we square root the whole thing, and it's equals to m over n. And then after that, we square both sides. Okay, and then we'll get x minus x1 whole thing square plus y minus y1 whole thing square over x minus x2 whole thing square plus y minus y2 whole thing square, and it's equals to m square over n square. Okay, so when PA to PB is equals to 1 to 1, okay, so we just put PA on the left and PB on the right, okay, and then after that we square both sides. Okay, remember this formula if you want to find the locus of a moving point from two fixed points. Let's look at this example. A point R, x, y moves so that its distance from two fixed points A, -1, 10 and B, 2, 6 is such that RA over RB is equals to half. Find the equation of locus of R. So this information is very important. Okay, so RA over RB is equals to 1 over 2. And then we do cross multiplication. So 2 times up and this one times up. Okay, so we'll get 2RA equals to RB. Okay, so let R to be xy over here, and then we have to use the coordinates of A and coordinates of B. Okay, and we put into the distance formula. So it'll be 2 square root, okay, of x for RA, yeah? Okay, x minus 1 will be x plus 1 whole thing square plus y minus 10 whole thing square, okay, and then square root the whole thing. So it's equals to, so for this will be square root of, okay, RB, yeah, will be x minus 2 whole thing square plus y minus 6 whole thing square, and then square root the whole thing. Okay, so now I'm going to square both sides to get rid of the square root sign. So become 4. So here will be, I'm going to expand all the brackets. Okay, so it'll be x squared plus 2x plus 1, then plus y squared minus 20y plus 100 in bracket, okay, equals to, so it'll be x squared minus 4x plus 4 plus y squared minus 12y plus 36. Okay, so I'm going to expand the left hand side first because there's a 4 outside the bracket. So it'll be 4x squared plus 8x, and then after that plus 4 plus 4y squared minus 80y plus 400, okay, equals to x squared minus 4x plus 4 plus y squared minus 12y plus 36. Okay, so now we solve this and everything move to the left hand side. Okay, so we do step by step. Okay, so here will be 4x squared minus x squared, so we have 3x squared. And then after that for y squared, so we have 4y squared minus y squared, we have positive 3y squared. And then for x, 8x plus with 4x, we have 12x. And then for y, we have negative 80y, and plus 12y, we'll get negative 68y. And then for the numbers, okay, we have 4 plus 400, and then we minus 4 minus 36, so we'll get positive 364, okay, and it's equals to 0. So that's the answer. Well, now that you have mastered all the basics of coordinate geometry, it's time for you to practice on some past year questions. Stay tuned to my next video, which is 10 years of past year questions on coordinate geometry, coming up soon. Bye!